Welcome to the word explanation for 613. In this particular case, we have some machine parts. We're given a diameter of 22 millimeters, but we are finding that diameters between 21.99 and 21.01, which is called tolerances, or which are called tolerances by engineers. So they'll still be acceptable. They'll still be considered to be good. In this case, the shafts for that fit into the valve hole. So the machining, we're finding that the machine mean, so the manufacturing process is producing a mean of 22.002 millimeters. So it's not 22 even, and there's a standard deviation of 0.005. So we want to find out the proportion of shafts that are between 21.99 and 22 millimeters. So in this particular case, you can see the average actual results are slightly higher than the target, and we also have some variability with a standard deviation of 0.005. So we want to find out, again, this is a slice between 21.99 and, in this particular case, 22 in part A. So this would be just below. So you find the Z-score of 21.99, find the Z-score at 22. You can see them on the screen as negative 2.4 and negative 0.44 compared to the actual results. The p-value, the area underneath the curve to the left of 21.99 is 0.0082, so just less than 1%. The area to the left of 22 is 34.46%, or 0.3466. The difference between the two is 0.3364. So 33.64% of these, the shafts will fit between 21.99 and 22. Now, in part B, we're also doing the same thing, but we're going in the other direction. We're measuring above. So again, you can see in part B, what is the probability that the shaft is acceptable? And remember, the shaft is acceptable from 21.99 to 22.01. So we're taking the slice out of the middle. Once again, you're given the Z values, and then your the spreadsheet that we'll have set up will have it set up so that we calculate the p-values, if you've done that, which again you are encouraged to do. So we see the area again to the left of 21.99 is 0.0082, like we did before. The area to the left of 22.01 is 0.9452. And the difference between the two, because we're dealing with a range, so in between, is 93.7%. So that means that 93.7% of the shafts are being manufactured within specifications or within the tolerances, which also means you have a defect rate that is the reciprocal of that of 6.3%. So they're either acceptable or they're not. In part C, you want to increase your quality from 93.7% to 98%. So the Z value at 98% is 2.05375. The value that you have is 22.0123. So you need to find, all right, in part C, the diameter that will be exceeded by only 2%. So this is the area above. So only 2% of the values will be above 22.0123 as the diameter. In part D, what would be your answers in A through C if you change the standard deviation from 0.005 to 0.004. So there's less variability. And it simply goes through the same calculations. So once again, you can plug those in to your Excel spreadsheet and very quickly get the same answers as what you're seeing on the screen. So it's just repeated from above.